Hello guys, this is Janika. Welcome to Learning Ladder of C language. In this tutorial, we are going to discuss more about an arrays in C language. In previous tutorials, I am explained about an array, how we can use an array in the C language, what are the types of an array, how the data are stored in the memories, and how we can retrieve data from an array. So in this tutorial, we are going to discuss what happens if suppose we are not follow the standard format of an array declaration. I hope that you all and view of in previous tutorial videos. Now, I'm taking a small example of a single dimensional array to store a 4 element integer data in it. So this array is represented with the variable a. So by using printf statement, I'm going to print an array element first which is stored in the 0th index. First, let's compile this program. I'm not getting any error, I'm getting one in the output screen. Here is a normal functioning of an array. If suppose what happens if suppose I'm not giving at this square braces and the index value in the sense, then compile this program. Instead of getting an element that is stored in first index, we are gonna get an memory address of an element that's stored in a particular address. To get an idea about this program, first let me see small diagram of how this happen in C language. Here I'm taking a small example of a single dimensional array 1 2 3 4, which is represented with an a variable, and a of 0 represents the value that's stored in the first 0th index, and a of 1 refers to the value that's stored in the first index. So when we look into in memory, then how these elements are stored in the sense they are gonna store in a sequence memory like 1 2 3 4 in the sequential order. And in this example, I'm gonna take a memory location that 2358848 is a starting memory location to store an arrays. So as I previously said, the array elements gonna store in a sequential memory. So for this reason, we are gonna get a sequential memory addresses. So as I stored in data of an integer, then the integer will take some 4 bytes of memory. For this reason, we are gonna get a 4 bytes difference between the two memory locations. While I'm compiling this program, with an a variable, then I'm getting a small address location. Let's see what the address location that we are getting. So we are getting 2358848. So indirectly, a as a pointer elements that gonna point to the elements in the array. So if suppose we are trying to print an a variable directly without mentioning the index value in the sense, then the C compile gonna return the memory address of a starting element that's stored in the 0th index. So if suppose we're gonna print an a directly, we are gonna get the memory address of an 0th index element. Indirectly, what it means in a is a variable that refers to an element that's stored in the array, but indirectly this a is act like a pointer to store the memory address of a starting element. Now let's see what happens if suppose some increment this a variable with 1. Let's compile this program. We're not getting any error, we are getting a memory location like 2358852. Now let's compile this memory with a diagram. We are getting in second element that's stored in an array's memory address. So by this we can have an idea that if suppose we are incrementing an a reference variable in the sense, then automatically we are gonna get as next memory address where the current pointer locating. So as I previously said, this a reference variable directly shows that property of a pointer. So we can use this a variable as a pointer. Let's take an example of a pointer p. Yeah, so directly we can store a reference variable as a pointer data type. So let's compile this program. We are not getting any error. So hence this a is an indirect pointer, points to the memory address of a first element in the array. So if suppose we are using an array, instead of using a pointer concept directly, we can use an a reference variable as a pointer. Let's see what happens if suppose I'm trying to print star a in the output screen. We are not getting any error, we are getting 1 in the output screen. This is why, because a is a indirect pointer which points to the address of a starting memory location. If suppose I wanna get a second element by using a pointer concept of a reference variable, in the sense I'm gonna increment this with 1, so indirectly it's going to refer the address of a second element, so we're gonna get second element value. Yeah, we are getting 2 in the output screen. If suppose you are applying an array concepts in our programming, in the sense there is no need to go for a pointers, directly we can use a reference variable as a pointer. This is the point that we have to have an idea. By applying the previously said concept, I am written a small program to print each and every element that stores in an array and the respective memory locations. Let's compile this program. Yeah, we are getting. If suppose I am mentioning an star operator before an a, the reference variable of a, so we are gonna get respective element that is the particular memory address. This star operator purpose I explained in the pointer concept. If you are not aware of it, then better you can view a tutorial video of mine. It's in the pointer concept. Yeah, we are getting the same elements. Yeah. Now let's see the same variable concepts in the multidimensional arrays. Here I'm taken as now. Let's see the same concepts in the multidimensional array. Before we are going for the programming part, first I'm gonna explain you a pictorial representation how these values are stored in the memory. For our example purpose, I'm taking a 3x3 dimensional array. Here 1, 2, 3 in the first one dimension, 4, 5, 6 in the second one, and 7, 8, 9 in the third one. So here the values are gonna store in the sequence of memory address location like this: 1, 2, 3, and followed by 4, 5, 6, followed by 7, 8, 9. So for our example, I'm taken memory address location of this first index value is 2358816. So next one will be 2358820, followed by up to 2358848. Like this, the elements are stored in the memories. Now let's go for a programming part. I declare a 3x3 matrix type of the array. Here I'm gonna store the values of 1, 2, 3, 4, 5, 6, and 7, 8, 9. In printf statements, I'm trying to print an element of a first dimension, first element, and followed by an a reference variable. Let's compile this programming part. Yeah, we are getting an element at the memory address location. This is similar to a single dimension. We are gonna get a first element and the first elemented data. Yes. Let's compile this with the diagram. Yeah, we are getting the same memory address location 2358816, the element and the particular memory address location. So same concept applicable for the multidimensional too. If suppose we are going to try to print an array reference variable directly, in the sense, then it's going to give an starting memory address location of the element. Now let's see what happens if suppose I'm incrementing this a reference variable with 1. Yeah, let's compile this program. We're gonna get some memory address location. Leave this first index value. We're getting memory address location. Let's compile this memory address location with the diagram. Yeah, we're getting 2358828. This 2358828 refers to the second dimensional first element. Now let me explain what happened. What is the reason that we are getting the address of a second dimension value? Incrementing a reference variable is different concepts on the single dimension multi-dimension. While we are going for the single dimension, there is no other dimensional value that were existed in an array. So for this reason, while incrementing a reference variable, it's not going to search for the next dimensional value. It's going to take a next memory address location. So for this reason, we are getting the second element address. But in the multidimensional, there is an exist of a multidimensionals that are in the array. So if we are incrementing an a reference variable, then automatically the C compiler will treat it as an incremented to the next dimensional first value. So this is why we are getting a next dimension first value address memory in the output screen. So if suppose I want to get a sequence in memory address locations irrespective to the dimensions, then we have to do a small modulation in the programming. Just we have to add a pointer before and a reference variable. First, let's compile this program. We have the memory address location at 235.88.20. Yeah, let's compile this output with the diagram. We are getting an address memory location of the second element that in the first dimension. So as same as the incrementing of a single reference variable in a single dimensional array, we can do the same operation in multidimensional also. So yeah, this is how these reference variables are treated in the C compiler. How we can use this reference variable to get in data from the memory address location. Thank you for watching. I hope that now you have an idea that what yeah, a reference variable, reference variable of an array will do in the C language. So thank you for watching. Don't forget to subscribe to get all for the next tutorial video.